sometimes it's nice to just sit down and do a straightforward chain rule question. So let's take a look at one. Here's my solution to the dailyintegral.com easy derivative for March 24th, 2026. The question asks us to find f prime of pi over 4, where the function f of x is equal to the square root of tangent of x. So the first thing I'm going to do here is I'm going to rewrite the square root of tangent of x as tangent of x to the 1/2. And when you write it like this, it looks to me like a chain rule question because there's an inside function, tangent of x. Tangent of x is being plugged into the square root, or in this case, tangent of x is being raised to the 1/2 power. So when you take the derivative of a chain rule question, you should be taking the derivative of the outside function, keeping the inside the same, and then multiplying by the derivative of the inside. So here, the derivative of something to the 1/2 is 1/2 something to the negative 1/2. You leave the something the same, but then you multiply by the derivative of that something. So that tangent of x pops out, and I have to multiply by the derivative of tangent of x. But the derivative of tangent of x is just secant squared x. So my f prime of x is equal to 1/2 tangent of x to the negative 1/2 times secant squared x. Now all we have to do is evaluate this function at pi over 4, and we get f prime of pi over 4 is equal to 1/2 times tangent of pi over 4, which is 1 raised to the negative 1/2, times secant of pi over 4, which is root 2 squared. But 1 raised to any power is 1, so that goes away, and root 2 squared is just 2, so you get 1/2 times 2, which is equal to 1. So the answer is 1. And this is a great question if you want to practice your chain rule derivatives, because you have to recognize initially that this function is a composition and then use the chain rule. And it's also great if you want to practice your values of sine and cosine, because you need to know what tangent of pi over 4 is and secant of pi over 4. So it's a great question. Hope you liked it.